So the topic of inheritance, we've already now talked about what exactly inheritance is. That's where you're creating a class and you're extending another class, meaning you're getting all the data and methods of that class, and then you could add more methods and data to that. And you can even override some of the ones you've inherited if you feel you have a functionality you want to do better than what you inherited. Okay, so the idea is, what we'll first start talking about is the possibility of inheriting from two different classes. So suppose we wanted to have a class. Let's say, so we have an abstract class, let's say called electronics. That would be just things that electronic components may have in common, but we've never actually, sell a person something that's an electronics, but we might sell them a clock, which is an electronic clock. We might sell them a radio, which is an electronic radio. So we might create a class called clock, which is a real class, not an abstract class, but it may have things in common with radios. So it might make sense for us to create an abstract class called electronics and store stuff in here like methods like power up. You plug it in and the thing turns on. What actually happens when it turns on, you would define it in clock or radio. Maybe in a clock, when you power up a clock, it'll set the clock to a certain time of day, some default time of day. Maybe a radio will set to a default radio station and a volume. But they both have something in common, is that they would power up when you plug them in. And maybe things that they would have in common might be they would display our company logo. Like all our products display our company logo and then go and do their own personal power-up thing. So we might create an abstract class called electronics, and then we make clocks from them, and then we make radios from them. Whenever we inherit from a class, we're basically taking the class that we're inheriting from and making it more specific. So it's not too common that we want to multiply inherit, but here's an example where we might. If we had a clock class and a radio class, we might want to make a clock radio. So functions that clocks have is like it keeps the time of day and sets an alarm, and when the time of day equals the alarm time, a sound goes off. And a radio might play a radio at a certain volume at a certain station. And we might want to make a very specific type of clock, a clock that is combined with a radio, which is a very specific radio. It's a radio that's combined with a clock. But this combination is somewhat rare. So now the question is, what would happen if the programming language allowed us to multiply inherit? So what happens is everything that is in electronics is inherited into clocks, and everything that is in electronics is inherited into radios. This would be if you have this diamond-shaped inheritance, where the two classes have a multiple base class, a common base class. So for example, in our electronics class, we might have a field like serial number. Maybe every product we make has a serial number, so we'd rather put that here than have them separate. Well, now if we had multiple inheritance, a clock radio would get two serial numbers, right? Because you get one for the clock and one for the radio, but maybe the clock radio should only have one serial number. So the programming language C++ allows you to do this, allows multiple inheritance. And they actually even added keywords, so you can say, give me one of these, not two of them, and give me the one that came in on the clock side, and don't give me the one that came in on the radio side. So there's keywords that, let you handle that. Other issues that come up is any method that appears here, you're going to get two copies of it, which probably isn't a big deal. When you go to call one of the methods, it would pick one of them, and they're both identical. But an issue would come up with this, let's say a method that appears here, the creators of the clock class felt it needed to be overwritten for some reason, but the creators of the radio class didn't. Now you get two copies, and you would have to know what the people from the clock class and the radio class, why one overrode it and one didn't. You'd have to know which one to pick. So if these were people working at a different company, you'd have to call them and ask them, what does your method do what it does, so you can decide which one to use. So there's a number of issues that come up when allowing multiple inheritance, and the creators of Java thought that it would be, that it's that the necessity for it is very rare. There's not too many clock radios in the world. You have animals and dogs and cats. There aren't any like dog cats, you know, so like the world doesn't have this need naturally, and it causes a certain error proneness to it. So the creators of Java decided not to allow it. So C++ allows it. The creators of Java and then C#, which came out a little bit after that, don't allow that. And these are, you know, some of the reasons why they decided to remove this capability from the language, to not allow you to multiply inherit. So the way we can kind of get around it, if we found ourselves needing to multiply inherit, and the language doesn't allow it, what we could do is we can, instead of having our clock radio class inherit from clock and from radio, we can have it inherit directly from electronics, and then we only get one copy of everything from electronics. And then in our class, we would actually declare a piece of storage for a clock and a piece of storage for a radio. Because effectively, when you create a clock radio, if it could inherit from both, we would create one and then it would get the storage from both of these. So now all we're doing is explicitly saying, get me a piece of storage with all of this in it, and get me a different piece of storage with all of this in it. So this looks like, you know, a pretty good way of almost doing multiple inheritance. And then what we could do is just create what sometimes is referred to as a wrapper class. So, for example, if the clock class, which extends electronics, had a method called setTime. So let's say you give it hours and minutes and it sets variables with it. So it takes age and sets it to hours, it takes him and sets it to minutes. Well, if we were able to multiply inherit, we would get this method automatically when we inherited from clock. We're not going to have that here because we're composing, we're using composition. We're creating a clock radio based on composing it of a clock and a radio. So we won't have a method called setTime. But what we could then do is, if we know what's going on in this class, is we can make a method called setTime, which calls the clock's version of it. So setTime would take in hours and minutes, and then we'd call the variable C, which is our clock. We call the variable C's setTime method and pass in those hours and minutes. So if we ever created a clock radio and wanted to set its time, we would call the clock radio setTime, passing in hours and minutes, and it will call on the C object, the clock object, its setTime, and then we call that setTime method. So then if, let's say we had this all set, and we think we have our classes set perfectly, all of a sudden the people who create the clock added a new method called setAlarm. And we just recompiled, we won't get a copy of this. Right? They would add this method. So setAlarm, they take hours and minutes and they set some fields. We wouldn't have those. We would have to know that they added this. Then we would have to create a wrapper function called setAlarm, which then calls this new method. So the thing that's nice about multiple inheritance, anyone adds something to this class, all we have to do is recompile and we pick it up. Now if they add something and we recompile, the method is there for us to call, but we don't have a corresponding method. So every time someone adds a feature to the clock or radio, we would have to know about it and add a wrapper class that calls it. So that's the only inconvenience. So what Java added, because it decided to not allow multiple inheritance, they added explicitly a thing called an interface, which is the word a lot of C++ users use whenever they created a class in C++ that only listed a couple of methods with no body to them, and someone inherited from them, which would then force the inheriting class to implement those methods. Those were typically referred to in literature as a C++ interface, but it was actually a class. So now they actually use the word interface to describe that behavior. So what that basically does, like if you think about it, let me go back to the diamond-shaped picture. If we were to allow multiple inheritance, then we would get the storage, we'd get two copies of the same storage coming into here. And if we had methods that were written here and overwritten here, but this one had a body too, and that body got inherited here, then we'd have two copies and we may not know which one to use. If the methods were just method signatures with no bodies, then whoever inherits from them would be forced to write them, so then that would remove the ambiguity of having a class that we're inheriting from. So an interface is effectively a class, but the methods don't have a body to them, forcing whoever inherits from them, or actually we're going to use the phrase implements them, to write the body for it, and then that takes away the error proneness to it. So interfaces are like classes in that interfaces are like classes in that they are compiled into bytecode files, named whatever your interface is, .class. They can be public, protected, private, or packaged. They can't be public unless their name matches the file name. Other than that, they can still be public. And they also can serve as a type for declaring variables. So I'll go over an example of that in a little while. Interfaces are different from classes in that you can declare only the header method and public constants. There are no constructors because there is no storage to initialize. They can't be instantiated, so you can't make an object of its type. But we can make references and have them point to objects that implement this interface. They can be implemented by a class. So that means a class is promising to provide the bodies for the methods that are in the interface. They cannot implement another interface, so it's like there's no inheritance in interfaces. They cannot extend a class. So an interface can't say, I have these methods, plus I inherit stuff from a class, because then you could pick up storage and methods that have bodies. And they can extend, you can extend several other interfaces. So an interface can extend another interface. That would be allowed. Okay. So the types that we can use to refer to objects in Java are now interfaces, classes, arrays, and then primitive types. So the syntax for declaring an interface is to say interface, the name of your interface, and then you list out signatures of methods that that interface would be able to, that classes that implement this interface would be required to provide the body for. We could say an interface, XYZ, extends another interface, ABC, and then we would list the methods that are related to X, Y, and Z. Then if a class comes along and says class C implements X, Y, and Z, X, Y, and Z actually has a bunch of methods and also extends A, B, and C. So we would have to write the bodies for all the methods in X, Y, and Z and A, B, and C, if we did an example like that. Okay, and the only thing different here was this didn't inherit from here. So here's an interface X, Y, and Z, here's an interface A, B, and C. They each have their own set of methods, method signatures. X, Y, and Z has its method signatures. A class can come along and multiply implement interfaces. You just can't multiply inherit. But a class C can implement A, B, and C, and the X, Y, Z interface. And then they have to go and write the bodies for all of these methods. So if you left one out, this won't compile. So you can't say you're going to implement an interface and then leave out any of the methods that you're promising to interface, to implement. So one example of an interface is, so Java actually defines over 600, it might be over 1,000 interfaces by now that come with the language. And so there's one there's one interface called a comparable interface. And what it basically is suppose you define an object like a person, and you want it to be able to say, how can you decide if a person is greater than another person? You know, like let's say you're going to do sorting. You're going to take objects and put them in order. What's greater than, less than, or equal to? How do you define that? Because a person is just something you made up. You have a first name, a last name, a date of birth. So if you wanted to say if person A is greater than person B, what does that mean? So what you can do is you can have your class, if you decide you want to put some kind of ordering to them, you can have your class implement the compare to interface, and then you can pass in, you then have to provide a function that returns any negative number if the thing you're comparing the main object to is less than, if you would return some negative number. If they equaled each other, you would return the number 0, and if it was greater than what you're comparing it to, it would return a positive number. Yeah?
Does Java have a thing like operator overloading, like you can say?
This is a sentence. Okay. Yeah, so that's from C++? Okay, that's a good point to bring up here. So what C++ does, and this is, like I say, Java came out about 10 years later, and I guess they figured these are improvements of it. But, so for example, you can create a class in C++, and then you can say the operator, you write a function called operator, and then maybe the equal sign, and then you define what it means for two things to be equal. Or you'd say operator greater than, and you define, so you could say something like, well, yeah, let me go over this example, and then talk about how C++ could do it. So for example, so things like, people and clock radios and so on don't have the concept of greater than, less than, or equal to, but maybe you'd like to define that. So what you can do is you can say a class student, which extends a person and also implements comparable. Now, because the interface comparable only has one method in it, and it's the method compare to, you're now required to supply it. And then in that method, you describe what it means to be greater than, less than, or equal to. So we could say that the student, so we pass in an object called, the object references O. Every object you ever deal with in Java inherits from this class called object. So you pass in an object, we take the object and we cast it to a student, so we turn it into a student. And then we say the one that got passed into us, we call it that. We're going to compare this to that. And then our object is referred to by the this pointer. So we can say if our age is less than the other one's age, then we return -1. If our age is greater than the other one's age, we return +1. Otherwise, we return a 0. So we're defining what it means to be greater than or less than. So we're using age. Whoever has, who's ever older is considered greater. But we could have done anything, right? We could have said whatever spelling of your first name, whatever our definition for greater than or less than for a person is, we could define it here. So what C++ did is you could add a method, function, that was called operator. Well, we'd have to do 3 in C++. We'd have to say operator equals, and then you define what does it mean to be equal. So we would say if the two ages equal, then we would return true, otherwise we would return false. Then we'd create another method called operator less than or greater than, and define what does it mean to be less than. So now, once you, in C++, once you had what we're calling operator overloading, you can define what it means to be greater than or less than for these objects that you're making up yourself. So Java got rid of that concept and added this compare to interface. So if you create a class, and for some, which is your own data, and then you want to somehow describe what it means to be greater than, equal to, or less than, you would have your class implement comparable, and then you would write a function compare to, which answers all 3 questions. Is it greater than, less than, or equal? All in one statement. Okay, so then the idea of, so now we have different ways to refer to use as a reference, different objects. So what we're allowed to do in Java, and the term is polymorphism, meaning taking on many forms. An object may be referred to by a reference that is of its own type. So we can create a reference of type clock radio, and it could point to a clock radio. anything it inherits from, so we could make a reference to an electronics and have it point at a radio, or a clock radio. That would be allowed. We can have an interface. So what would be a good idea for an electronics interface? What's a function, like maybe a power-up interface, like let's say we made a rule that all electronics have to be powered up. So we could have something that's a type, the interface power-up, an object of type power-up, and it could refer to a clock or a radio or a clock radio or anything like that. And then we could also refer to something by an interface that was from a class that it inherited from. So examples of polymorphism would be something like this. So suppose we had, now that we're getting good at implementing and stuff like that, suppose we had an electronics class which is abstract, so just a reminder of last class. An abstract class is a class that you would never instantiate. You would never say, this object is of type electronics. It's only used for inheriting purposes, but it has something that all these classes have in common. But we could decide that we're going to implement the powerOn interface. And the powerOn interface may be a collection of functions that happen when you power something on. Okay, so now clock extends electronics, radio extends electronics. These are not abstract classes, so we can actually make these things. And then we've decided to let clock radio extend from electronics and do that composition way of simulating multiple inheritance. Okay, so we're allowed to create an electronic object, call it EC, and have it actually refer to a clock. That's allowed. Even though this is of type electronics, this would be of type clock. Now, using this object to call a function that is only specific to clocks won't work. So we couldn't say like EC dot set time, because electronics don't have a way of setting their time that's specific to clocks. Okay, we could say electronics ER is equal to new radio, that's allowed. Electronics ECR is a clock radio, that would be allowed. And this is also allowed, so we have an interface called powerOn, so we could call this a powerOn object, and we can let that refer to an electronics which is actually pointing at a clock, or referring to a clock at the moment. That would be allowed. And then we could say EC power-up. So in this case, the power-up is a function that is in the powerOn class, in the powerOn interface. And if an electronic, ER is an electronics, which happens to be referring to a radio at the moment, if that had a function called print serial number, we can call it, because the print serial number function is actually defined in electronics. So that would be allowed. But if we pick the clock radio and then call the set time, we want to set the time to 3:20, this would not be allowed because the ECR is of type electronics, and the compiler doesn't have a method for set time in electronics, only has a method in set time in clocks. So we could take a clock reference and have it equal the clock radio, and then refer to it with the clock reference. That would be allowed. But we couldn't refer to it directly from the electronics reference. Even though what the electronic clock radio reference is pointing to has a method called setTime, the compiler won't know what this is pointing to as your program is running. It can't follow as you're moving references around what it's going to be pointing to. So it's going to tell you we don't have a method called setTime in the electronics class. So you wouldn't be able to call that method. Okay. So yeah, just another example, just to not keep going over the clock radio example. Suppose we had an abstract class called shapes, which implements an interface called Drawables, and Drawables are any shape that you could draw, and maybe it has methods about drawing it. And then we had a class called circle, which extends shapes, and we had a class called square, which extends shapes. So those are specific types of shapes. We could then make a drawable reference. So it's not referring to a class, it's referring to an interface. And then anything that is in drawable, we can call on these objects. So we can have a new circle and have it referred to by a drawable reference. A new square, have it referred to by a drawable reference. And then we could say, we could call on the drawable reference, we could call the draw method, as long as the draw method is in drawables, and obviously we would have to have implemented that method. So we would call the drawable method on a circle. And then we would call the draw method on a square. Now, if there was a method called area, the area of a circle, the area of a square, and those were inside of these methods, we wouldn't be able to say A equals ds area. I think this 320 was just a leftover from the previous slide. I'm trying to set a time for 320. But anyway, so with that not there, we wouldn't be able to call functions that are in circles or squares because they're not inside the interface. Okay. Okay. So yes, anyone have any questions about the interfaces? And that's kind of, I think, the gist of the gist of it is basically why were interfaces added to the language? Why does C++ not have interfaces? And it's because C++ has multiple inheritance. So as a way of removing some error proneness to the programming language, the creators of Java, who were also creators of C++, they just basically created C++ in New Jersey and then moved out to California and created Java. They decided that it wasn't worth allowing multiple inheritance. It was more of a headache than it was a benefit. So they removed it from the language, but realized that a lot of the error proneness would not happen if the classes you were inheriting from didn't have their own bodies to their methods and didn't have storage that would be in common with other storage that you're inheriting more than once. So the idea of an interface, which is effectively a class that has a bunch of methods with no bodies, doesn't hurt to allow you to multiply inherit those. So they just decided to give it a different name, call it an interface, and allow you to inherit as many of those as you want. But you can only inherit from one class. That was kind of their compromise. And then if you find yourself in the situation where you actually genuinely need to multiply inherit, like creating a clock radio, or a particular type of clock is a clock radio and a particular type of radio is a clock radio. If that scenario comes up, you can do it with composition. So you use composition, and then every method in the clock class and every method in the radio class, you just have to write a wrapper. It's usually one line long. Same name as the method, but you just call the method on the object you're composing with. And that generally works out.